Okay, so welcome to the fifth class of design patterns and framework. So today we are moving into another design pattern, which is adapter design pattern, which is the fourth design pattern that we are discussing. So if we go through the list that we have been discussing, so in the first two lectures we discussed singleton design pattern and factory design pattern, which are the creational design patterns. And then last week we started our discussion on structural design pattern. We started with facade, and today we are moving into another structural design pattern, which is a adapter design pattern. So if you go back to the OOP principles, object-oriented programming principles, today we mainly looking at the interfaces. We have been looking at encapsulation, object and classes. Of course, the object and classes constructors are there. So today we are looking at interfaces mainly. Right. What is an adapter? I'm pretty much sure you have come across an adapter in your day-to-day life. So when you want to connect from one interface to another, which are not compatible. Now I remember during few years ago when we had HDMI cable, HDMI port rather, there are many devices which doesn't have the HDMI cable. Mostly they had VGA cables. So we had to use a converter. We had to use a converter, adapter. Another classical example is when you want to convert between PS2 ports to USB ports. So these are very common examples in our life. The adapter design pattern is used to communicate between two non-compatible existing systems by providing a compatible interface. So when you have non-compatible interfaces, which you need to connect, may be to communicate, may be to retrieve data or send data. So adapter design pattern will use as a connector between these two uncompatible interfaces. And typically in development world, we use this as a wrapper class. Wrapper. So for example, let's say input is XML format, right? So let's say our input is in XML format. And then if you want to right? So let's say our input is in XML format and we want this to be written in JSON format, right? If you look at, it's a very, very simple example. Most of the time, this is the classical example that people are use. That is because XML is a little bit legacy format. Most of the size now we are looking at the JSON or PARQ file format. So if you want to convert these two, you write a wrapper class. You don't do anything. You input the XML and convert into a JSON. Right? So that is the whole idea of a common wrapper class. Right. Now we have a question. If interfaces are incompatible, why can't we change them? We know for a fact that they are incompatible. So can't we change it? You can't, because these interfaces are most of the time are third-party libraries, third-party web services, where they don't provide any different formats. They have a configuration And for example, they will say the output is on XML, or they request XML format where you have to provide it. Remember, we were discussing event-driven programming in last semester. In event-driven programming, we discussed we are dealing with multiple different types of the devices. These devices are third-party devices. So when you want to communicate between these devices, they have a different format. They're expecting a different format. Therefore, you can't change these interfaces. You have to support those. Then the question is, right, so you can't change the interfaces, but you can't change the client. Now, what we are saying is, there is incompatibility between client and the interface. So you can't change the interface, but can't we change the client? No, you can't again. Why? This client may be connecting to multiple devices. Remember event-driven programming, right? So because of that, this client might be sending in different formats. XML is one format, JSON is one format, Parquet is another format. So if you are not, if you are, you can't stick to a one format always, right? So therefore, there are situations where you can't, neither the client nor the interface cannot be changed. In that particular scenario, you have to use an adapter. That is where this design pattern comes handy. Right, so this is a high level architecture. So client and the adaptee connected through a adapter class. Where we can use this? We can use, mostly this is used for third-party libraries where you don't have a control over it. And then system integrations, you are integrating with another system, legacy system, right? Where you need to run, connect between multiple systems. Web services, it's a sort of a third party, right? Sort of a third party where uh, third party web services you need to deal with. System upgrades. Now you're upgrading systems. Old system to a new system, legacy system to a modern system. In those cases, you will have different interfaces and clients. You have updated your client, but still your interfaces may be requiring or maybe sending in the previous format. In that type of situation, we need an adapter in between. Right, the implementation. So as I said at the start, we will be doing we will be using interface concept in OOP. Hope you remember what the interface is. Interface is a template. You define only the signatures of the methods, where you implement them in the derived class. Right. So interfaces, you can recall the interfaces, what the interfaces are. So what happens here is we have so web client calls to a web request interface, and web adapter is implements from the interface. You can see here it has a same request object is implemented here. Now what happens here is you have the web client, and then this web service expecting a JSON format, but you get your input is you are getting it from a object format. So here what happens is adapter, you have the object format coming in and you convert it to a JSON format, and then you connect to the web service. So what this does is it converts object data type into a, sorry, the integer data type into a JSON format. It can be Excel to JSON. It can be integer to Parquet. Sometimes you may have to have multiple adapters if you are connecting to different types of web services. So this is what we call as a wrapper class. Right, let's see how the design is done. Now we have a public interface, right? Remember the term interface, web request, where you have only the signature of the method. Remember, we have only the signature of the method. Then, so we implement adapter from the web request interface. Again, if you remember our OOP knowledge, when you are implementing from a interface, we use the keyword called implements, not the extend. Extend is to uh, uh, for inheritance we use it, but here we want to derive, we want to implement a class from an interface. And then you can see in this implement, in this web request interface, you had this method, and now we are implementing the method here, right? So we are implementing the method here. So we get the object request and we convert it into as an output, and then this is we convert this one object from into the JSON format. Then, so this is where the client, where we send the request to the adapter, right? And then this is the final implementation where you call this web service and then you call the adapter, and from adapter you are calling the web service. Right. Now, what are the characteristics of what are the characteristics of the adapter design pattern? So when I'm saying that, I'll go back to the previous slide. So remember this slide. So we have the client, target interface. It's connect through the adapter, and there is an adapter. So here what happens, client and adapter classes have incompatible interfaces. That is why we have this. So client and adapter, ideally what we want is, we want this to be connect directly to adapter. That's the whole idea. But however, due to incompatibility of this interfaces, we can't do that. So therefore, we have to bring the adapter design pattern. Right. So client and adapter classes have incompatible interfaces. Adapter is a wrapper class that wraps the adapter, hiding it from the client. So if I go back, even though client has to directly connect to the adapter, he can't due to the incompatibility. So it connects to the adapter, in which it hides it's wrapped the adapter. It wraps the adapter and hiding the implementation. Then client send requests indirectly to the adapter by using adapter target interface. Ideally, client wants to send the message to the adapter, but due to the incompatibility, it sends the message to adapter interface. Adapter translates the request sent by the client class into a request that the adapter class is expecting. So what the adapter does is, it translates the message that you are getting, let's say XML format, into JSON format. Right. If you are using databases, you have something called data adapter. Now, What does it do? Just think. This is, you have the web application. You need to connect to a database. Which database? It can be any database. In the relational database, here I have listed few. You have the SQL Server, you have OLDB sources, other data sources. Now, as a developer, it's little difficult to manage different types of databases. But because of the data adapter, it converts, you send the select request or whatever, adapter converts that query that can be run through all of these databases. This is a classical example for adapter design pattern. Right. Now, I told you last week, the facade design pattern and adapter design pattern are similar, but they are different. If you look at the Microsoft video, which I have shared last week, you will see they are discussing facade and adapter together. Why? They are little similar. Now, in the adapter pattern, you are trying to alter the interface so that your client do not see any difference between the interfaces. So adapter, you are trying to alter the interface so that your client do not see any differences between interface. Client adapter, adaptee is expecting JSON, but you are getting an XML. In adapter class, you convert it so that client does not need to know what the adaptee needs. Now, but facade, what it does is, it simplifies the interface. It simplifies the interface. If you remember, in facade, we have different roles. If you go back to the example we discussed during the class, we have a travel booking scenario. I want hotels to be booked. I want flight details for flights to be booked and transportation to be booked. They have three different capabilities. They have three different roles. So you combine those roles into one. In adapter, you have the same object but different interfaces. Different interfaces. Right. What do you think? Adapter design needs more code. Do you agree? Yes. You need more code because you have a new class. However, payoff is great. Now, especially in legacy systems, sometimes you're expecting in different formats. So, for example, I have a practical experience here where we were upgrading data from COBOL to some other data technology. If I recall correctly, it's Access. We can't say because what happens in that particular example, if I draw quickly, so these were COBOL files where users are writing it to the COBOL files. These were little legacy systems. And then there are reports which cannot be executed directly on here. So what we did was we had a database in Access format and adapter converts data from here to here. So instead of reports, we'll connect to here Access file the database instead of connecting to COBOL. Right? So there are a couple of adapters we implemented, right? So in order to use them much efficiently. Right. Okay. So this is what we discussed last week. Remember the scenario. How can a facade design pattern be used to streamline the process of booking vacation package that involves interaction with multiple services, flight booking, hotel reservation, and car rental. For some reason, flight booking part hasn't come off nicely. So just imagine this is a flight booking part. So in Facade, what it does is it combines all these three different services into a one platform. Adapter. Now look at this. Now what if hotel, this service needs multiple web services which will have different formats. One can be XML, another one can be in JSON format, another one would be in some other format. It can be adjusted with data value. But here you are expecting, let's say this is the latest one, so it's expecting a JSON format, but you are getting it in XML format. You have to do an adapter there. And you are getting it in a CSV format, comma separated values. You have to convert that into XML form. So what happens here is a hotel reservation is connected to multiple web services. Right. So let's look at some examples, real world examples as per your request. So these are the examples that we discussed during the class last week. So I thought of, we discussed these examples for the facade design pattern, but you can see you can extend them into adapter design pattern as well. So I'm not going to take each and everything, but I'll take a couple of examples. Banking system. Now you are going to have a new loan approval module. But you are expecting data in a legacy API that is coming from old banking software. Right? So I have given the examples here, how these implements in each and everything, right? So you can look at these things and we can discuss this in detail during the class. So idea is how the adapter design pattern and facade design pattern can be implemented in these given scenarios. List is not limited to 7, but see, because we discussed 7 examples rather, during the class, we'll be looking at these patterns. Thank you very much for watching this. Also, this week you have a bonus. From this week onwards, you have a bonus, that is, you will get a additional video, that summary video, which describes things in 5 minutes. It's available in the eCal, also in the YouTube channel as well. So there are no grading for that. You can watch this as a summary of what we are discussing. Please note, it is generated from Notebook LM, and it is from my slides. It is generated from it's generated from Notebook LM using my slides, these slides. So in case there are disparity, please note, right? They are LLM tools. They are the AI tools. Also, I have uploaded the memory map, mind map as well, again generated from Notebook LM. So I can't guarantee the accuracy of this. It's up to you to verify whether they are correct. So they have uploaded for you to get a more knowledge on this factor. So let's discuss this in detail when we meet at the classroom. Thank you very much. See you next day.